So hello, my name is Anthony Capper, and welcome to Talk Tech with Turtle at Tuesdays at 10 a.m. And today I'm going to be talking about modern OT network migration. So also my role here is ASB service specialist, and let's hop into this. So the first thing I want to talk about is, do you face any of the following issues? So there's plenty of issues that go on in a plant that control engineers could face day to day. So we're going to mention some of these relevant issues and see if they sound familiar. So here are some problems within OT infrastructure. The agenda I'm proposing to discuss throughout this presentation will be focused on these 6 typical issues. So our first issue we have is downtime caused by unstable architecture. An example of this can be unmanaged switches. Next, we have cyber risks caused by flat networks. An example of a flat network could be all devices being on the same VLAN. Next, we have compliance and audit exposure. An example for this would be failing to comply with federal regulations. Next, we have IT and OT misalignment. An example for this would be having IT and OT have confrontation on their goals. Next, we have lack of visibility and control. And an example of this would be not being able to see your assets and lifecycle status. And finally, we have infrastructure that cannot scale. And for example, we can talk about outdated hardware like a PLC that can't take more than a certain amount of connections, or legacy infrastructure that's limiting growth. So these are 6 typical issues that we see within an OT environment. And now we're going to start to talk about some possible solutions. So we're going to highlight these first 2 problems, which is lack of visibility and control, as well as infrastructure that cannot scale. And our solution here would be industrial assessment. So first, we need to be able to see what we have in our panels in order to be able to have any type of guideline going on. So many OT environments struggle with limited visibility into their control panels and infrastructure, making it very difficult to understand what assets exist, how they're connected, and whether the hardware is outdated or approaching end of life. This lack of visibility often leads to infrastructure that cannot scale because organizations are trying to expand systems without fully understanding the current network or device lifecycle status. So now we have a lot going on the screen. This is what we like to call the Converged Plant-Wide Ethernet, CPWE. So for a network that's unstable and chaotic, this is the structure we want to look at when it comes to a baseline on how we talk networks. This is what we want to achieve. This is our goal. So after completing an industrial assessment and gaining visibility into the assets and infrastructure within the plant, the next step is organizing that environment into a structured and scalable architecture. This is where Converged Plant-Wide Ethernet, CPWE, comes in, providing a proven framework and reference architecture. So now let's talk about what we have on screen. We can see the very bottom of the screen, we have levels 0 to 2, which is our silent zone area. Then we have our industrial zone, which is more in the middle, levels 0 to 3. Above that, we have our IDMZ zone. And on the very top, we have enterprise zone, levels 4 and 5, which would be typically IT. So now we're going to jump into what we can see during an industrial assessment, which would be levels 0 to 2. So in the bottom corner, we have 3 different topologies. We're going to start with star topology. So a star topology represents a physical arrangement of devices where each device has a minimum connection to a central switch. So pretty much all of these devices are connected to that one central switch. Next, we have ring topology. So for a ring topology, we have multiple switches connected in a ring format with devices connected to every switch. Now we call this a ring because one port in the switch is disabled, so it avoids becoming a loop, which would cause failure. And lastly, we have a linear topology, which represents one switch connecting one after another with devices connected to each switch. So these are the 3 main topologies we talk about when it comes to a network. So now we're going to be talking about our solution install base evaluation. So CPWE provides the framework for how we talk modern OT network migration and how it should be designed. But the first step in applying that framework is understanding the current environment through an install base evaluation, otherwise known as IBE. So an IBE allows us to inventory existing assets, identify obsolete or high-risk equipment, and establish the baseline needed to move forward with network modernization and vulnerability assessments. So from there, organizations can progress from the IBE into deeper services such as network and vulnerability assessments, helping to move from understanding their infrastructure to actively improving reliability, security, and lifecycle management. So you can see at the bottom of this image, it says find weak points, fix vulnerabilities, and improve performance. The way I like to talk about it is you can't fix what you can't see. You want to find these weak points before they become something worse. It's like you want to go to the doctor to get checked up because you don't want anything else to happen. So once we find these weak points, we can avoid the vulnerabilities becoming something within our network, and then that overall improves our performance. So now I'm going to talk about some of the outcomes of an IBE. So these are some of the solutions by services that we talked about in previous talk text with Turtle. And we have two of our service team members here, Sandra and Rachel, to help us provide these LCS solutions listed below. So now I'm going to be talking about a little bit about each LCS solution and the purpose behind them. So first we have Inventory Plus. What is Inventory Plus? So pretty much it's a contract that allows you to have spare parts on hand of your assets, whether that's on site or within Rockwell. Next, we have Repair Plus, which is having a contract for repairs for either old or new equipment. Next, we have Learning Plus, which is train your team with any Rockwell-based hardware and software. So say your whole factory were to upgrade to a certain piece of hardware, and you wanted to keep everyone on the loop, get them all trained and up to date. That's where Learning Plus would come in with your online training subscription. And now ISA, what is that? So ISA takes all these contracts and puts it into one, and we like to call that an integrated service agreement. All right, so now we're going to be jumping into our next two problems, which is downtime caused by unstable architecture, as well as cyber risk caused by flat networks. So our solution here is implement redundant network architecture like PRP, DLR, and ring topology, as well as move from a flat, unmanaged to a segmented and managed network. So pretty much legacy OT environments were built using flat network designs and unmanaged switches, which provides little control over traffic and can introduce serious risks such as network loops, lack of visibility into devices, and increased cybersecurity exposure, often resulting in unstable communication between PLCs, HMIs, and drives, and ultimately leading to an unplanned downtime. So by migrating to segmented architectures with managed industrial switches and implementing redundant topologies like PRP, DLR, device level ring, organizations can create this deterministic communication path, gain network visibility and control, and prioritize critical assets, and significantly improve reliability and cybersecurity across their OT infrastructure. So I'm going to be talking about now a little bit about media evolution in OT. This is one of our problems, downtime caused by unstable architecture. This can be our example here. So before we really start talking about switches and network architecture, we first need to understand the evolution of communication media in OT environments. So older systems often relied on coaxial cabling, which supported basic communication but provided limited bandwidth and flexibility. So as industrial networks evolved, we moved from Ethernet-based infrastructure like Cat5, Cat6, and now Cat7, which supports higher speed, better reliability, and modern industrial networking. So most modern PLCs and industrial devices today are designed for Ethernet communication, not coax, making Cat6 the preferred option for performance and scalability. Another challenge with coax is that replacement hardware and parts are becoming harder to find, while Ethernet infrastructure is widely available and easier to maintain. So if a coax network fails today, repairing it can be difficult and expensive. And just a side note, coax cables, they had about 100 megabytes per second speed with communication. Fiber is up to, well, Cat 6 and fiber up to gig, 1 gig and further. So it's a real difference, 10 times the speed. We also have, going forward, unmanaged versus managed switches. So this slide highlights the difference between unmanaged and managed switches within OT environments. So unmanaged switches simply pass traffic between devices with no control, prioritization, or visibility. This can lead to unpredictable communication between critical assets. Now, managed switches, on the other hand, allow us to configure, prioritize network traffic, giving priority to devices like PLCs, HMIs, and drives. The Stratix 5200 specifically is an optimized industrial switch developed by Rockwell and Cisco. So industrial managed switches like the 5200 also include security features, diagnostics, network segmentation, monitoring, and faster troubleshooting. So a particular unique feature are enabled within these switches are enabled macros for fast configuration and profiled industrial devices. So this is a key step towards building a stable, secure, and scalable OT network architecture. So now we're going to be looking at the next problem and the solution. We have cyber risk caused by flat networks, and our solution would be vulnerabilities and threat detection. So historically, Rockwell Automation addressed OT cybersecurity through multiple individual vendors and solutions such as Dragos, Cisco Cybervision, and Verve, which could make the cybersecurity conversation complex for customers. Today, these capabilities are unified under Secure OT, a Rockwell cybersecurity framework and strategy first, which then leverages those platforms to provide asset visibility, vulnerability management, and threat detection across industrial networks. So Secure OT simplifies how we talk about and implement cybersecurity in OT environments by aligning these tools, standards, and services into one approach that helps organizations monitor assets, identify these vulnerabilities, and protect critical infrastructure while supporting modern industrial network architectures. So, our last two problems of the day, we have external factors of compliance and audit exposure, as well as IT and OT misalignment. So our solution here would be adopt an OT cybersecurity standard, like a NIST Framework 2.0 or IEC 62443 Industrial Security Architecture. So compliance and audit exposure, along with IT and OT misalignment, can no longer be treated as internal operational decisions because what was once managed solely by the end customer or factory floor is now being driven by federal mandates, customer requirements, and evolving standards such as TSA cybersecurity directives and pharmaceutical validation processes, forcing these organizations to modernize OT network architecture to remain compliant and insurable. So since older PLCs were engineered for availability and integrity, not confidentiality, aligning OT with modern cyber standards now require OEMs, system integrators, and manufacturers to implement segmented, monitored, and standards-based networks infrastructure that proactively meet these regulatory expectations while also closing that IT and OT gap. So let's jump into a little bit further about that. We want to talk about the compliance and misalignment. So this slide highlights several external forces that are now driving the cybersecurity and governance in OT environments. First, we can see in the top left, we have TSA directives, which represents government regulations that are increasingly requiring critical infrastructure and industrial organizations to implement stronger cybersecurity controls, incident reporting, and network visibility. Next, we have pharmaceutical validation. In industries like pharma, once a process is validated, you cannot easily change the way a system operates because even with a small change could alter the outcome of that product, which in some cases could impact patient safety. This makes modernization and cybersecurity updates much more challenging. Next, we can see CISA, CISA, Security Infrastructure and Security Agency, which provides guidance on vulnerabilities, threat intelligence, and remediation practices for industrial environments. So now on the more technical side, we have platforms like Kali Linux, which is commonly used for security testing, exploration, and vulnerability discovery, showing how attackers and defenders can analyze OT networks. And finally, we have Windows environments, which receive frequent security updates. This highlights a key difference between IT and OT, as IT systems are updated regularly, while OT, like PLCs, are historically not. However, with these increasing cyber threats, firmware updates and lifecycle management in OT are becoming much more necessary. So overall, these external pressures and evolving threats are pushing organizations to adopt these stronger cybersecurity governance, patch management strategies, and documented controls across their OT infrastructure. So this is our summary, talking about the future-ready OT network. So modern OT environments were originally built for reliability and availability, but today they must also meet the growing cybersecurity regulatory and operational demands driven by these external forces, such as the TSA directives, CISA guidance, and industry validation requirements. So by migrating from a flat, unmanaged infrastructure to a CPWE aligned segmented network with these managed switches and resiliency architectures like DLR ring topologies, organizations can reduce that downtime, improve your visibility, and build OT networks that are secure, compliant, and ready for the future of industrial connectivity. So you have all these services, all these ways to talk. This is our team. This is the services team. So within modern OT network migration, it's not just about the technology. It requires the collaboration of lifecycle services. So cybersecurity strategy and networking expertise to fully modernize and secure this critical infrastructure. So our team at Turtle and Rockwell Lifecycle Services work together to help customers assess, design, and implement OT networks that are reliable, secure, and ready for our future. So that's it. We're done for now. So thank you so much. I hope you guys enjoyed. If you have any questions, please feel free to reach out to our team. And I hope you get a lot of knowledge about OT infrastructure.